Hello, this is the second part of our Objective 10 review. The first topic we will go over today is writing an equation for a function after a vertical and horizontal translation. In this topic, you will be given a function and a picture of the graphed function, along with the second graph, which is the translation of the original function. You will be asked to write the equation of the second graph. Key concepts in this topic to remember here are: the graph of y equals f of x plus or minus a represents a horizontal translation. If it's minus a, so you have x minus a, then you shift the graph a units to the right. If you have x plus a, then shift the graph a units to the left. Also, the graph of y equals f of x plus or minus b represents a vertical translation. If it's minus b, then shift the graph b units downward. If it's plus b, then you shift the graph b units upward. For example, here's a problem in ALEX you might see. The graph of f in blue is translated a whole number of units horizontally and vertically to obtain the graph of g, which is in red. We have the function f defined by f of x equals negative 1/2 x squared. And so we're asked to write the expression for g of x. To figure out the vertical and horizontal translations, let's focus on the vertex of each graph. In other words, let's figure out how many units horizontally and vertically the vertex of f of x has been translated to obtain the vertex of g of x. From the graph, we can see that f of x has been translated 3 units to the left and 2 units down. Therefore, from the rules of translation, the horizontal translation is negative 1/2 times the quantity of x plus 3 squared. So we added the 3 into the x in parentheses and then squared the whole thing. Then, to shift the graph 2 units down, we must subtract 2 from the whole function. So the final answer ends up being g of x equals negative 1/2 times the quantity of x plus 3 squared minus 2. And that's our final answer. Again, remember that with a horizontal translation, it has to do with what is being added or subtracted directly to x inside the parentheses. A vertical translation has to do with anything added or subtracted to the whole function, as in the second part. The last topic we will go over for this video is graphing an absolute value equation in the plane. With this topic, you will graph functions of the form y equals a times the absolute value of x minus b plus c. Absolute value graphs always have a v-shape, and to find the vertex, we can first find the x value by setting x minus b equal to 0 and solving for x. Then, the y value of the vertex is the value of c. And we can prove that if we were to plug or substitute b into the function and then solve for the y value. Once we have the vertex, we need to find a point on each side of the vertex in order to finish the graph. This will be done by choosing an x value on each side of the vertex and substituting it into the function to solve for y, then plotting the points. Here's an example in ALEX. We have y equals 4 times the absolute value of x plus 4 minus 3, and we have to graph this equation. So we'd find the vertex, and then we would find a point on each side of the vertex and then plot the function. So we need to find our vertex. First of all, we'll identify that 4 is b and 3 is c. We will set x plus 4 equal to 0 and then solve for x. So if we set x plus 4 equals 0, we'll subtract 4 on both sides, and the result will be x equals negative 4. So this is the x value of the vertex, negative 4. And then we see that the y value will be negative 3, based on our c value being negative 3. And this is what we will plot on the graph, negative 4 comma negative 3. So we'll plot this point now, negative 4 comma negative 3. And there's our vertex. And we see that this is a positive coefficient, so we know that the graph will open up this direction. It will open up upwards. So we need to find a point on the left and one point on the right. The best option for this would most likely be to choose the x value of -5 and the x value of -3, just because these two x values are the two closest to the vertex. And we'll substitute -5 and -3 into the function and solve for our y values. For x equals -5, we'll have y equals 4 times the absolute value of -5 plus 4 minus 3. The absolute value, so -5 plus 4 is equal to -1, and the absolute value of -1 is +1. So this is equal to 4 times +1 and then minus 3. 4 times 1 equals 4, so 4 minus 3 equals 1. So we have y equals 1. Then, for x equals -3, we'll have y equals 4 times the absolute value of -3 plus 4 minus 3. -3 plus 4 is equal to +1, and we have 4 times 1 is 4 minus 3. So we would see that y equals 4 minus 3 equals 1. So we'll then plot -5, 1 and -3, 1, which we can see shows symmetry in the graph. -5, 1 and -3, 1. Check to be sure. -5, 1, -3, 1. And then we can use our graphing tool to draw our rays. We want to use the ray tool, not the segment tool. And you do it for both points. So we did it for the left side, now I'll do it for the right side. Place your first point here again, and then the second point there. And this is our final graph. And then we'll want to check to make sure it's right, and then we would move on. Again, for this topic, remember to find the vertex by setting x minus b equal to 0 and then solving for x. Then we can find the y value of the vertex by looking at our c value, whatever is added or subtracted to the entire function. And once we have our vertex, we will then choose an x value on each side of the vertex, preferably the two closest values, plug those into the function, solve for y, and then we will have our two other points, then plot the 2 points, and then graph the function. And that's how we graph an absolute value equation in the plane.